Hello, this is Professor Kuehn. Welcome back to my lectures on space, time, and motion, where we are talking about projectile motion. Last time, we talked about a particular problem, how to find the range and the time of flight of a launched projectile. Now let's do another problem. This involves finding the muzzle velocity of a cannon. This is particularly relevant for the laboratory exercises that we'll be carrying out this week, so pay attention. Suppose that you consider a cliff, a high cliff that looks like this, and you were to put a cannon on the top of the cliff that would launch a cannonball horizontally. So imagine you have this cannonball that you fire out of the cannon, and at the moment it is shot, it has some initial velocity. We'll call this the muzzle velocity. And this is what we are going to try to find. How do we determine muzzle velocity? Well, we can do that if we know two things. If we know the height of the cliff and also the range of the projectile. So suppose that the projectile follows the trajectory something like this, and we were to measure how far it goes. That is the horizontal range of the projectile. And we also knew the height of the cliff, h. Could we work backwards and figure out what the muzzle velocity of this cannon is? And the answer is we can't. So how do we go about doing that? So the question is, how can we find the muzzle velocity of the cannon? And as before, we're going to make two simplifications, and I would say oversimplifications. But here they are. We're going to assume that there is no drag. That is, we're going to neglect any effect that the air has on the cannonball. And we're also going to assume that the Earth is perfectly flat. That is, we're going to assume that the curvature of the Earth in no way plays a part in this problem. Okay? So how do we find the range? The first step we're going to have to do is we're going to have to find how long it's in the air. In other words, we want to find the time of flight. How do we know the time of flight? Well, if we know the distance that it falls, the height, and let's suppose that the height, let's just use a number here. Suppose the height was 45 meters. That's the height of the cliff. And let's suppose the range that this was fired was 1,200 meters, or 1.2 kilometers. We could determine the time of flight, that is how long it's in the air, from the height of the cliff alone. How do we know that? Because the horizontal motion of this cannonball in no way affects the rapidity with which it drops. In other words, this will hit the ground in the exact same amount of time as if you were to simply drop the cannonball off of the cliff. Well, if that's the case, then we can find a relationship between the height and the time of fall. And that would be that the height through which it falls is equal to 1/2 the acceleration times the time squared. Or, inverting that, we can find that the time is equal to twice the height divided by the acceleration, and take the square root of that. Well, that's pretty straightforward to do. Let's plug in our numbers. You get twice. The height is 45 meters, and the acceleration is 10 meters per second squared. I'll go ahead and put meters in here, and then you take the square root. Well, 2 times 45 is 90, divided by 10 is 9, and the meters cancel out. We have 9 seconds squared under the square root, or 3 seconds. That's the time that this is in the air. There we go. We have the time of flight. I know I didn't specifically ask for the time of flight, but that's going to be useful in determining the muzzle velocity. So step 2 to this problem is finding the muzzle velocity. Well, if we know that its horizontal speed is constant, which is the presumption in projectile motion, that's because we're assuming there's no drag. If the horizontal speed is constant, then we know that the distance that it travels horizontally is just going to be equal to whatever the horizontal speed is times the time that it's in the air. Well, what is the horizontal speed? It's just going to be the muzzle velocity, because the muzzle velocity is the horizontal speed because the cannon is shot horizontally. So what we can do is we can solve for the horizontal velocity as the total distance it travels horizontally divided by the time of flight. That will be the same thing as the muzzle velocity. Well, what's the horizontal distance traveled? That would just be the range. And what's the time of flight? Well, we just computed that, t. There we go. Let's plug our numbers in. 1,200 meters divided by 3 seconds, and so we get a muzzle velocity of 400 meters per second. That is the horizontal velocity, which just is the muzzle velocity of this cannon.